Hello everyone! Tonight I'm going to be giving you an introduction to the work of the British Dragonfly Society and how all of you can get involved. My name is Eleanor Culver and I'm the Conservation Officer for the BDS. And firstly, I'd like to thank you for inviting me to speak on the run-up to International Women's Day. Thankfully these days there are far more opportunities for women in the conservation job market. For example, our entire team at the BDS is currently made up of women. However, there is still a significant imbalance at the top of the career ladder within the conservation sector, with most of the leadership roles held by men. Anyway, enough moaning. My journey into the world of conservation started at Bangor Uni, where I did a degree in zoology with conservation. And I chose Bangor because I was obsessed with reptile life. I then went on to do a master's degree in biodiversity and conservation at Leeds, where I discovered that birds were pretty cool too. And as a result, I decided to undertake a warden internship with the RSPB, which led to a stint as a senior research assistant studying raptors. And this generally led me to become obsessed with boggy places and their inhabitants, including dragonflies. During this period, I also did work experience at schools with ecologists and held down various jobs in pubs and cafes, etc. So if there's any lesson to take away from this, it doesn't really matter if you don't really know what you want to do straight out of university. You may need to explore a few options. And in fact, having a kind of variety of experience can actually be of use, as many jobs in conservation require you to be a bit of a jack of all trades. Anyway, I eventually ended up at the BDS where I can obsess about dragonflies and bogs all day long, which is great. Now, I'm sure you're already familiar with the dragonfly life cycle, but I just want to go over and recap some of the basic dragonfly facts. Actually, I lie. I'm going to let YouTube do it for me.
Here among the reeds surrounding ponds that feel gross when you step in them live some extraordinary creatures. They are in the order Odonata and have existed for more than 300 million years with only minor changes. Here, the majestic dragonfly. Well, that moment's ruined. And the Damselfly. Really? I'm trying for gravitas here. This looks like a stalker you'd feel sorry for. Alright. While the dragonfly may have gotten luckier at the naming ceremony, these damsels are not of the in distress variety. More like, f*** with me and I will bite your face off. The ones you never really hear about in the fairy tales. To understand the marvel of biology and engineering that is the odonate, we must begin in the waters below. Their lives begin as cute little larval nymphos. Nymphs. Unlike the caterpillar, which takes a time out in a sleeping bag to transform into adulthood, odonate larvae continuously molt, shedding their outsides up to 17 times before they reach their adult form. These cute little babies are carnivorous hunters from the start. When they are small, they eat small things, like the tiny crustacean Ostracoda. Kind of looks like he's just eating the faces off those things. More into the cookie than the cream, as my mother used to say. As they grow, however, they devour almost anything they can catch with the moxie of a drunk college student who found half a breakfast burrito in their mini-fridge. Some nymphs stalk their prey out in the open, while others, like skimmer dragonfly nymphs, are ambush hunters, taking a page from the bobbit worm and hiding in their hidey holes before they pounce. They will even, on occasion, eat their own. And just a side note here, but if you're planning on doing this, start with the head. But first, cannibalism is not a good look for any species. Nobody wins. Odonate nymphs hunt using their labium, plural. Important distinction, the following has nothing to do with the human labia, which thankfully has not evolved in this direction. Yet. The odonate labium is like a weaponized lower lip, At rest, it is tucked up beneath the head like a bent elbow, and it has the ability to shoot out suddenly and grab or impale unsuspecting prey, pulling them back to the mouth in between two serrated edges or grasped in specialized pincers. These labium are powered hydraulically. Water is drawn in through the butt, as it should be, and a good clenching creates enough internal pressure to cause the labium to pop out like the eyes on one of those little squeezy stress dolls. You can try this at home. All you need is a bathtub, a muffin, and a go-get-'em attitude. Nothing will happen, but you might lose a roommate. Now, the anus of the dragonfly nymph is not your ordinary run-of-the-mill anus. Let's try this. Close your eyes. Go ahead and picture an anus. Put a little hat on it if you want. Whatever you're thinking right now, it's not that. That is your very own imaginary anus. You're welcome. You can keep it. Unlike the damselfly, which has external gills, the dragonfly nymph's gills are inside its butt. No judgment. That is where it breathes. At the end of the dragonfly nymph abdomen, it has something called an anal pyramid. Trust me, don't Google this term. This isn't a pyramid made from anuses. That would be different. This is 5 rigid structures that can close the nymph's butt, which helps it with the butt breathing, but also assists in locomotion. Water can be expelled forcefully in a sort of fart jet, allowing it to avoid predators, chase prey, or just do it for fun. I would. I'm doing it right now. After up to 6 years in the water, the odonate nymph is near its final transformation. An intricate system of tubes within its body will have to transition from getting oxygen from its gills to breathing air through spiracles, little holes in its body's external surface. This hardcore little bastard leaves the water behind and ventures out into the world. It finds a perch, and like a hipster trying to get out of a pair of tight, skinny jeans, it must wriggle and contort itself. With one final sit-up, it is free from the last shell of its larval skin. I have to say, that looks like it would be very satisfying. Like popping a zit, except you are the zit, and what comes out of it. Adult odonates may live for only a few weeks or up to a year, and with mating season approaching, it's time for fairy wings and fur. Kind of like getting ready for Burning Man, but without the arguments over who's bringing the weed and who's bringing the nutter butters. The newly emerged adult is teneral or soft and must harden while blood-like hemolymph is pumped into its swelling veiny wings. Damselfly adults generally have long, slender abdomens, wide-set eyes, and wings that rest like a roof. They have names like Eunice or Marvin. Is he cleaning his butt with a raindrop? It's like a line from a poem. Dragonflies tend to be a bit more meaty, eyes closer together, and wings spread out at rest. They have names like Dave or Carol. While human entrance to adulthood is marked by pimples, useless hair on our genitals, and college debt, the adult odonate gets frickin' wings. We totally get screwed. These 2 pairs of ultra-flexible wings look a bit like stained glass windows that were made by a coke addict being attacked by a squirrel, who was also a coke addict. Each wing is attached to the thorax by separate muscles and can be maneuvered independently, allowing it to fly upside down, backwards, basically however it wants, reaching speeds up to 30 miles per hour. To catch their prey, they have traded in their labium for 3 pairs of legs, each with a flexy foot ending in a pair of claws. The front legs are often conveniently equipped with little spiny brushes that are used to clean their ginormous frickin' eyeballs. These magnificent balls of eye can see in almost all directions and are built from 30,000 highly sensitive pixel-like ommatidia that can sense all sorts of light, including ultraviolet wavelengths, the ones we use to look for stains on motel room bedspreads, which is why you never see a dragonfly in a motel. Very kissable lips on this one. All of these parts, wings, legs, and eyes, come together in a symphony of death. But these are no ordinary hunters. In laboratory settings, scientists have used their sciences to observe odonates catching 90% of the mosquitoes they stalk. Their tiny little brain can hone in on a specific insect and appears to be able to predict where it's heading. It then coordinates its head, body, and wings to find an optimal flight path which disguises its motion as it approaches. This allows it to intercept its prey in a sort of aerial ambush rather than just chasing it from behind. From a scientist's point of view, this is a marvel of nature. From the mosquito's point of view, it's more like... nom nom. But the hunter can also become... well, dead. Lauren had ironically just taken up knitting. Joshua responded to a Craigslist ad for flying lessons. And although Libby was great at avoiding frogs, she is currently under the windshield wiper of a Hyundai. Those that survive, however, are ready for sexy time, which is slightly more complicated than whatever took place to make you. The odonate penis is located on its second abdominal segment. However, its gonads, the parts that produce sperm, are located down on the ninth segment. In technical terms, there is a great distance between the nutsack and the timmy. Like if you had testicles hanging down on your ankles like the little bells on an elven shoe. To mate, the male must put his gonads in contact with his penis to transfer sperm. Then, using claspers on the end of his body, he grasps a female's head. She then curls up her genitals to meet his mid-belly penis. And what a penis it is! It has specialized bristled lobes which are used to scrape out the previous suitor's sperm, so that things don't get mixed up. Think of it as putting that little divider in between your groceries at the checkout line. And imagine that your groceries were sperm. Same, but different. Try finding this position on Pornhub. It's complicated. Sometimes you have to watch to figure it out. Oh, that's nice, giving him a closer view. At the end of the female abdomen, there is a single genital opening and a small ovipositor, which will be used to deposit her fertilized eggs. After mating, males will often stay attached or hang out nearby to help out, but also to make sure that their sperm doesn't get scraped out by some other dude. Some females, like this southern spreadwing damselfly, lay eggs inside the stems of plants, even venturing under the water with an assist or diving solo. This young couple is in search... oh, forget it. For some, a nice bit of mud will do. Maybe baby wants the pond scum, or maybe the eggs are placed right freaking over here and here. However it happens, the circle of life for the odonate is now complete. David, no, I need you to push. David, all right. Now pick a place and push, okay? David, oh, Jerome, could you show David how to push? All right. David, you realize that's making it harder for me, not easier.
So now that we've been reminded about how awesome dragonflies are, I'm just wanting to talk a bit about the work of the British Dragonfly Society. So we're only a small charity made up of 5 members of staff, and we have roughly around 2,000 members at the moment. And one of our main tasks is to run the national recording scheme for Odonata in Britain. And just to let you know, you can find all the information about our recording scheme and how to enter your records on the BDS website in the recording section. All our data is entered onto the online iRecords database, where the data is checked and verified by our team of volunteer county dragonfly recorders. And your county dragonfly recorder is our volunteer Alan Brandon. His details are here if you're wanting to find out more about local dragonflies, or you can look up his details on the BDS website. All the data on iRecord is then exported to the National Biodiversity Network Atlas database, where it is publicly available for anybody to use. For example, in the past it's been used by researchers globally to do trend analysis on dragonfly species, and it's used by local authorities and ecologists in the UK for things like assessing the biological impacts of new developments. So we encourage all members of the public to get involved in dragonfly recording. You don't need to be a complete expert in dragonflies to get involved. Every record that is entered is valuable and is useful. For beginners, we usually recommend learning to identify, record and report a few easier species starting off, and starting with learning to identify males. This is because in most species they generally show less variation in colour forms, and they're often territorial, which means they're easier to spot around the water's edge than the females. So I'm just going to go over 4 quite common species that you can find in North Wales, starting with the large red damselfly, or as I like to refer to it as crazy eyes, because it has these mad patterns on its giant eyeballs. So this is a species that's generally first on the wing at the beginning of the flight season, starting off from May through to June, and it can be found at a variety of habitats apart from fast-flowing water. If you see a red damselfly in North Wales, it's almost 100% likely to be a large red damselfly, so it's quite easy to identify. And the males have a black thorax with red antehumeral stripes. Those are the red shoulder stripes you can see. Red eyes, black legs, and a red and black abdomen. Females are relatively similar to the males in appearance. They generally have yellow antehumeral stripes on the thorax and a varying amount of red, yellow, and black coloration on the abdomen. Second, we have the blue-tailed damselfly, which is often described as looking like a magic wand. And this is generally in flight from May through to July, and can be found at a variety of lowland wetlands, apart from, again, fast-flowing water, so kind of small ponds, slow-flowing canals, that sort of thing. The males have blue antehumeral stripes, the shoulder stripes, and mostly black abdomen, apart from segment 8, which you can see is a paler colour. Blue-tailed damselfly is actually my favourite damselfly, because the females come in a crazy variety of colours, ranging from blue to pink, but they generally all still have the black abdomen with the pale spot on segment 8. There is another species of bluetail called the Scarce bluetail damselfly, which you can find at a couple of upland sites in North Wales. However, given the name, you guessed it, it's pretty rare, and also it's found in different habitats to the bluetail. It's usually found in upland habitat. And also it can be told apart by looking at the end of the abdomen. So you can see that in the bluetail, the blue coloration on the end of the abdomen only covers one segment, segment 8, whereas in the Scarce blue-tailed damselfly it crosses 2 segments, segment 8 and 9. Here we have a common species of dragonfly, the 4-spotted chaser, and this is a species that you find around shallow ponds and lakes. Both the male and the female are very similar in appearance and hard to tell apart. They have a browny black coloured body with yellow spots down the sides of the abdomen, and they also have 2 black spots on the leading vein of each wing, and also a dark wing base on the hind wings. And no other species of dragonfly in Britain and Ireland has these wing spots, so they're hard to misidentify. Lastly, we have the emperor dragonfly, the beast, the biggest dragonfly in the UK. This is a species seen in kind of June to September time at well-vegetated, still or slow-flowing wetlands. And I mean, it's one of the brightest coloured dragonflies in the UK as well, with the bright blue abdomen and green thorax, so really quite difficult to misidentify. Lastly, we have the emperor dragonfly, the beast, the biggest dragonfly in the UK. This is a species seen in kind of June to September time at well-vegetated, still or slow-flowing wetlands. And I mean, it's one of the brightest coloured dragonflies in the UK as well, with the bright blue abdomen and green thorax, so really quite difficult to misidentify. Females can come in two colour forms. The first has a green thorax and blue abdomen, so is very similar in appearance to the male, while the second has both a green abdomen and green thorax, but it still has the black lateral stripe running down the back of the abdomen. A couple of sites around Bangor that I would recommend visiting include Park Menai. There are a few ponds here where you should be able to find a selection of damselflies like large red damselfly. If you catch the train to RSVB Conway, you should be able to see a larger variety of dragonflies on the wing amongst the reed beds and around the ponds, such as emperor. If you head into Snowdonia, it's worth visiting Corsboggoeth. Apologies if the pronunciation of that was wrong. And this is home to a range of peatland wetland species such as common hawker and keeled skimmer. It's also worth heading over to Anglesey to Maltraeth Marsh, Triple SI. This large area of marshland and small ponds should provide you with the opportunity to see a variety of species, including hairy dragonfly and southern hawker. If you're looking for resources to help you get into dragonfly identification, there's the free identification help guide and resources on the British Dragonfly Society website. If you're looking for a downloadable book, the Nature Guides, Dragonflies and Damselflies of Britain and Ireland Field Guide is available to download if you have an iPhone. But if you're after a book, then I'd recommend the Britain's Dragonflies by Dave Smallshire and Andy Swash, and the Field Guides to Larvae and Exuvia of British Dragonflies and Damselflies by Steve Cham. Dragonflies are one of the easier groups of insects to learn how to identify because there's not that many. There are roughly 46 resident and regular migratory species that inhabit Britain and Ireland. Of those 46, roughly 25 inhabit North Wales. And when you see a species, there are a number of steps you can go through to help you identify it. Firstly, work out whether it's a dragonfly or damselfly. Then look at the habitat it's in, because some species are specialists of certain habitats. For example, they might only breed in fast-flowing rivers and streams or in heathland wetlands. And thirdly, what time of year is it? As we saw earlier, species have different flight times, so this is something important to consider also. We encourage recorders who are familiar with their local species to adopt local sites, to conduct complete list surveys at least 3 times a year over the flight period, which runs from May to September. A complete list survey consists of literally just making a list of all species observed during a visit. And these visits must only be conducted on warm, calm days, which are the best conditions for surveying dragonflies. And this data goes towards the production of our atlases and analyses of trends in changes in dragonfly species occupancy. So occupancy is literally just how many 1 kilometre squares, for example, a species was seen in 1 year compared to the next year. Occupancy changes in some species cannot be studied by adult surveys alone. For these species, we have targeted species projects, for example, our recent Northern Damselfly project. This endangered species can only be found in Scotland, in the Cairngorm National Park area, Deeside and North Perthshire. Its habitat includes both acidic and neutral waters, ranging from large lochs, small, well-vegetated ponds, to bog pools and acidic basemires. Volunteers are encouraged to search potential sites as well as known sites with historic records for adults but also larvae. Looking for larvae for this species is very valuable because weather conditions up in its upland range are generally quite cool and wet, which makes adults less active and harder to find. Thankfully, their larvae are easy to identify due to the ridge on their caudal lamellae, which you can see here. We also run targeted projects on specific species of interest, such as the Willowed emerald damselfly, a recent colonist that was first seen in large numbers in the UK in 2009. We've been recording its spread across England since then, starting with its first colonies that established in East Anglia, and it can now be found as far north as North Yorkshire and as far west as Warwickshire. Identification features of this species include its pale brown wing spots and a spur-like marking on the side of its thorax, and these can help you distinguish it from other emerald species. Also, in winter, you can check willow trees around the edges of the species wetlands for ovipositing marks. These are little knobbles left on the bark of willow tree branches where the female has inserted her eggs. So, using the data sets collected from these various recording projects, the BDS enlisted the help of statisticians at the Biological Records Centre and the UK Centre of Ecology and Hydrology to analyse the records from the past 50 years, so from 1970, to produce the State of Dragonflies 2021 report. And the report looked at 1.4 million records roughly from over 17,000 recorders. The statisticians used occupancy detection modelling, and this looked at species presence absence across the UK at a level of 1 kilometre OS grid squares. If the number of grid squares in which the species was recorded increased, then its occupancy increased over time, indicating that the species was becoming more widely distributed. Obviously, we can't sample every 1 kilometre grid square in Britain and Ireland, so the model also carried out its own random sampling and measured the probability of species presence, which made the dataset a bit more robust. From the data, they were able to produce these maps, which show species diversity by hectad, aka the number of species that have been recorded. A hectad is a 10 kilometre by 10 kilometre square. So on the left we have a map showing all records up to and including 1990. On the right we have a map showing all records up to and including 2019. And as you can see, there is a general pattern of increasing species diversity spreading up from the south. And this is generally a result of many species which have historically been restricted to the south, or rare migrants to the south, increasing their distribution, moving north in the UK and colonising new wetlands. So here we have the overall results. So 41% of species, that's 19 in total, increased significantly in occupancy. 11%, so 5 species, declined significantly in occupancy. And 22 species show no significant change, 48%. And in addition, we had 5 that increased and 3 that decreased in one or more countries, but not overall in Britain and Ireland. Emperor Dragonfly showed the greatest increase, 56% in total for Britain and Ireland. In the 1990s, it was largely confined to low-lying areas of southern England and South Wales, but since then it spread both westwards and northwards. It reached Ireland in 2000 and has rapidly spread throughout the country, and the species has been recorded from parts of Scotland since 2003. Emperor Dragonfly showed the greatest increase, 56% in total for Britain and Ireland. In the 1990s, it was largely confined to low-lying areas of southern England and South Wales, but since then it spread both westwards and northwards. It reached Ireland in 2000 and has rapidly spread throughout the country, and the species has been recorded from parts of Scotland since 2003. Just to point out that the grey area on the graph represents a 95% confidence interval, which basically means that the computer model is 95% confident that the true value lies within the range represented by the grey area. So the thinner the grey area around a blue dot on the line on the graph, the more likely it is that the blue dot is an accurate value. Migrant hawker showed the second largest increase, so 28% in total for Britain and Ireland. It particularly increased from the late 80s, as you can see on the graph. As you might be able to guess from the title, this used to be just a rare migrant to Britain and Ireland. However, it can now be found breeding across most of Ireland, as well as low-lying areas of Wales, the south coast of Ireland, and a few sites in the south of Scotland. Emerald Damselfly showed the greatest decline overall, 14% for Britain and Ireland. And this was quite a surprise because this is considered still a relatively common species. The decline was mostly in England, 17%. Second is Black Darter, which has shown an overall decline of 12% over the past 50 years. Again, this decline has mostly been in England, but also Northern Ireland and West Wales. So now that we know how the distribution of species in the UK has changed over the past 50 years, we need to find out why. And the state of dragonflies has given us plenty of hypotheses to test in the future. I mean, for one, we know that insects are particularly sensitive to changes in climate, and dragonflies are no exception. So climate change is likely to be a significant driver of changes in distribution. As our climate warms in Britain and Ireland, the climate envelope for species, who are originally limited to the warmer south, increases, allowing them to move further north, and this is likely to be the driver behind the increased distribution of emperor and migrant dragonfly. Both these species also have the benefit of being strong flyers, who are able to utilise a range of still and slow-flowing wetland habitats for breeding. With increasing summer temperatures, wetlands are also at greater risk of desiccation. For example, this year our Scotland recorders witnessed the desiccation of numerous upland bogpool sites, which are home to the azure hawker, which is an endangered species. This has led to extinction in some areas, as their larvae are unable to survive out of water for long periods. This could also be behind the decline we've witnessed in emerald damselfly. This species is associated with shallow wetlands, so naturally these are vulnerable to desiccation. This species is actually adapted to coping with short periods of drought. The species lays its eggs in wetland vegetation, so the eggs are safe if the wetland pools dry out. The eggs then hatch in spring once the pools have refilled, and the larvae quickly develop and emerge before the ponds dry out again. Of course, this adaptation doesn't work if the pools dry out too early. Of course, dragonflies' wetlands are impacted directly by human land management, which can result in habitat destruction, fragmentation, or degradation. This is likely to have fed into the decline we've seen in black darter, particularly in England, a species which relies on peatland wetland habitat, similar to what you can see on the screen. In upland areas, drainage for afforestation and agriculture has resulted in the destruction of habitat in the past 50 years. Another cause for habitat degradation is actually a lack of management and grazing, which leads to the succession of heathland habitat and the development of scrub, which leads to the desiccation and succession of their remaining heathland habitat. As an insect that spends most of its life underwater, water quality is also obviously a significant impact on its survivorship. However, our understanding of the sensitivity of different species towards different forms of pollution is still limited. For example, we've always thought that the blue-tailed damselfly was very tolerant to pollution. Often it's found in wetlands where no other species seems to be able to survive. However, according to the State of Dragonflies report, it has actually shown signs of decline in recent decades, which has made us reevaluate this assumption. According to the EA, the three main causes of water pollution include untreated sewage, runoff from agriculture, and runoff from urban areas. There have been great improvements in reducing sewage output over the past 50 years. Pesticide and fertiliser runoff continues to be a major cause for concern though. Obviously in the UK 70% of our land is agriculture, and use of pesticides and fertiliser is widespread. Recently you'll probably seen in the news that the potent insecticide thiamethoxam, I think I said that right, has been legalised for use on sugar beet crops to fight viral outbreaks, which is causing quite a concern among charities such as the BDS and Bug Life. Microplastics have been increasingly gaining attention in research over the past 5 years or so. Odonata larvae can ingest microplastics either directly by accident or ingest smaller invertebrates that are contaminated with microplastics. The impacts on Odonata and their survivorship is currently limited. However, there is evidence of bioaccumulation further up the food chain. For example, the accumulation of bioplastics in fish has been shown to cause intestinal issues as well as impact their metabolism. So, as well as guiding our future research, the State of Dragonflies report will help us identify species in trouble and in need of safeguarding from human activity. Coincidentally, the quinquennial review of Schedules 5 and 8 of the Wildlife and Countryside Act are currently underway. This is legislation that provides legal protection to species from human activity that would either directly hurt or kill them or destroy their habitat. So as part of the review, the criteria to qualify for scheduling has been updated. and species must now have a red list status of endangered, and there must also be evidence that human activity is directly responsible for the species' endangered status and has directly negatively impacted populations recently. So these criteria have caused a bit of controversy. For one, just because a species isn't currently impacted by human activity at the moment, and human activity isn't a major threat, it doesn't mean that it won't be in the future. Also, if a species is endangered, then any loss as a result of human action could have a significant impact on the species' survival in the UK. For example, the Norfolk hawker is currently listed under Schedule 5. Its stronghold is in the Norfolk Broads and the northeast corner of Suffolk. However, it can also be found in a few other counties, including Cambridgeshire and Kent. But because this species is the main threat to the species is climate change, specifically sea level rise, which threatens its stronghold in the Norfolk Broads. This species has been identified for removing from the schedule, which I'm not sure I particularly agree with, but there you go. As part of the review, the BDS has requested that the northern damselfly be added to the Schedule 5 list. This is another endangered species, and so therefore it qualifies under the first criteria, but also there is evidence of a number of planning applications up in Scotland that are currently threatening a few of its populations. A lot of these are related to the development of new roadways. Also recently, a breeding pool was destroyed to make way for a Tesco at Aviemore, so that's another bit of evidence of the direct impacts of human activity. Because the state of dragonflies has outlined such dramatic changes in the distribution of so many of our resident species, it's become quite clear that we need to do a review of our Odonata red data list for Great Britain, which was written back in 2008. For example, the dainty damselfly is currently listed as extinct on the red data list, but in fact can be found breeding in the southeast of England. Dainty damselfly was recorded in Essex during the late 40s and early 50s, but became extinct during a great coastal flood. But the species successfully recolonised the Isle of Sheppey in North Kent back in 2010, and a new population was discovered in the Sandwich Bay area of Kent back in 2019. Sites that support red-listed species and priority species, we encourage their landowners or volunteers to carry out long-term monitoring projects here to keep an eye on the health of these species populations. This requires monitoring the species abundance, which can usually be achieved by doing counts of the adults. And this approach is also encouraged at sites where landowners want to assess how Odonata populations are responding to changes in habitat management. Monitoring projects methodology usually involves setting up a series of transect walks or survey points within a site, whichever is more suitable, which are to be revisited and surveyed year on year. Odonata activity is greatly affected by time of day and weather conditions, which in turn affects the likelihood which you're likely to see different species. So these variables are usually recorded as well. In some cases, it might also be useful to record breeding activity, such as copulation or ovipositing. Also, you might want to record larvae or exuviae, as these are valuable in ascertaining whether a species is successfully breeding within a site. Some species, however, require specific monitoring techniques. For example, the near-threatened common clubtail, which breeds in England and Wales. This species spends most of its adult life feeding in the canopy of riparian woodland, so it's quite a difficult species to survey as an adult. The species breeds in lowland, slow-flowing, mature rivers, and has very localised populations. Because the adults are hard to spot, it's much easier to set up a transect survey along riverbanks looking for their exuviae, which they leave behind after they emerge. And these exuviae can be found on kind of exposed riverbanks, riverside trees, man-made structures such as bridges, usually less than a metre above the water, and are generally a lot easier to find. Long-term monitoring can be useful for exploring the effectiveness of new management tools and conservation tools as well. For example, the BDS has been involved in setting up Odonata monitoring projects as part of a number of beaver reintroduction projects at sites including Willowed wetlands in Derbyshire, where beavers were released last year. As natural landscapers, beavers' damming activities create larger areas of wetland habitat. By cutting down trees, they're creating sunlit conditions favourable for dragonflies. And also they're very good at digging ditches, which creates new habitat. Again, new sheltered small wetland areas for breeding Odonata. At Willington, we set up a series of transect survey walks, and in addition, they're using drones to monitor changes in the vegetation and the waterways along these transects. So hopefully we'll be able to see and study how the Odonata populations are responding to these changes. The only problem is that beavers tend to make things a bit waterlogged, and your survey routes tend to get a bit soggy after a while. In some rare instances, a reintroduction is a tool that's used for helping some of our rarest dragonfly species. For example, white-faced darter is one of our rarest species in England and can only be found at a handful of sites in the Midlands, Cheshire and north of the country. The species is limited to breeding in deep pools on bogs, and these bog pools need to have dense sphagnum moss mats, which are used for egg laying, and the larvae also use them as refuge and for hunting. Reintroductions have so far been successful at Delamere Forest in Cheshire and Falshore Moss in Cumbria. A couple of years ago, another reintroduction began at Drumborough Moss, run by the Wildlife Trust, up on the Solway coast. All reintroduction projects are pretty simple and basic. They basically involve moving buckets of bog water with a sphagnum that contain eggs and larvae from a donor site to the reintroduction pool, and this process is repeated over 4 years. Reintroductions such as this require monitoring at the donor site and to ensure that the removal of eggs and larvae isn't having an adverse impact on the donor population. And long-term monitoring is of course required at the reintroduction site to ensure that the reintroduction project has been successful and the species has colonised their new site. Partnership and working with organisations such as the Wildlife Trust is a big part of what we do, since we don't own any of our own land or have any reserves. And a big part of this is providing advice on and support on surveying and monitoring dragonflies, providing local information and data on dragonfly populations, research into Odonata ecology, and habitat enhancement and restoration. For example, a couple of years ago, we joined in partnership with the Ministry of Justice to provide them our advice and support on all the subjects above. The Ministry of Justice has its own ecology team and is one of the biggest landowners in the UK with 10 SSSI sites within its estate. Obviously it benefits us if they can survey their sites and enhance them for dragonflies, and we're happy to help them do so. As well as working with NGOs and private landowners, a big chunk of what the BDS focuses on is working with the public to champion dragonflies and their wetland habitats. Our team of volunteers run a range of events from field courses to family events across the UK every year. You can find these events on our website. This weekend I'm going to be in Stoke-on-Trent making pipe cleaner dragonflies with children. I think I must have made at least 1,000 pipe cleaner dragonflies by now. Obviously over the pandemic we've had to scale back our events, and we've taken to social media to perform most of our outreach campaigns, and took the opportunity to create new campaigns such as Pond Watch, which runs every June. And this is aimed at sharing the wonders of ponds and inspiring those fortunate enough to have gardens to manage them for dragonflies and potentially dig their own pond. This campaign was run with the assistance of volunteers such as filmmaker Steve White, and I've shared a little video he made at home.
Welcome to Pond Watch Live from my pond in Somerset. I've got a underwater camera here, attached to this projector screen behind me here. So I'm going to take it underwater in the pond and see what we can see, especially hoping to see some dragonfly larvae. So here we go. I dug this pond 3 years ago. The pond is 6 foot wide, 8 feet long, and about 80 centimetres deep at its deepest. And you can see now the water is absolutely thick with tiny animals. In a couple of weeks' time, emperor dragonfly larvae will start emerging from this pond. But at the moment, the larvae are still underwater, where they've been for the last year or two of their lives. Ah, dragonfly larvae there. Oh, they're staring right at us now. There we go. I think we've been spotted. Quite a late stage, probably just short of his final molt. And still actively hunting, I'd say. Look at that, that's fantastic. This is the labial mask, the projectile jaw. It's hydraulically operated. There's a hinge in the middle and then it can fling out and grab prey. I think this one is actually a southern hawker, just from the shape of the head. The emperors will be leaving in a couple of weeks. They're the bigger ones, biggest British species. Southern hawkers are pretty similar, pretty hard to tell apart. I do have these two little, well, large silhouettes. This is a southern hawker, more buggy eyes, and this is a emperor with more slanted, longer eyes. There they are. That's a snail, in case you're wondering what's coming out behind him there. Oh yeah, wow! Oh, he's going to go for that phantom larvae. Is he? Ooh. That is an emperor dragonfly, I would say. That little white tube there. Can you see it through there? Let's see if we can get a bit closer. Here we go. That ghostly colour suggests it's just molted. They molt several times during their lives. They look very pale for a few hours while they're hardening up still. Pretty vulnerable at this time, I guess. What's that there? Ah, wow. Okay, no, that is amazing. That is a Damselfly larvae. Okay, so that is tiny, so I am amazed I'm seeing that. And I guess he'll be coming out any day now. So he's about that long, maybe. And when they come out, when they hatch out, they're translucent, really hard to see until the damselflies take off. I think this is a common blue damselfly, but I'm not entirely sure. I'd have to check that in a book. Just needing to shelter from a marauding diving beetle. Another damselfly larvae. And this one could be in trouble. Ooh, not this time. This emperor larva's got a snail stuck to his head. Ow! That doesn't look good. Now the snail's a vegetarian, but that can't be comfortable. Unless he's providing a cleaning service like a turtle cleaning station with little fish cleaning the algae off the larva, but I've never seen that before. Ow. Right, battery's gone on my lights. So that's it, that's the end of Pond Watch Live.
So as part of our new strategy, which we have just drafted, we are wanting to increase accessibility to the British Dragonfly Society, and that includes students. So if you guys or anyone you know is interested in getting involved in our social media campaigns, such as Pond Watch, obviously there are other things you can get involved with too, such as recording. We have annual publications which we send out to members, our membership magazine, as well as a monthly e-newsletter which you can sign up for free on the website. And we are hoping to improve our connections with universities in the future to try and promote Odonata, as they are a understudied group. But to be honest, we're just happy to hear from students and things that they're interested in, and any ideas on how we can improve the society for the benefit of students wanting to pursue the study of Odonata, wetland conservation, or entomology in general. So thanks for listening. I hope I haven't sent you all to sleep, but if you want to get in touch, please feel free to do so. Here's my email address.